Did you know that scientists have actually created a time machine? Well, sort of. They've developed a way to send particles back in time, even if it's just for a tiny fraction of a second. While it's not quite the kind of time travel we see in movies, it's still a remarkable step in understanding the complexities of time itself. Time travel has always been a fascinating topic in science fiction, captivating our imagination with stories of adventures through the ages. From time loops to future cities, the possibilities seem endless. But beyond the realm of fiction, theories in physics suggest that time travel might not be entirely impossible. The concept of moving through time, visiting different eras, and experiencing the past or future has intrigued humans for centuries. And while we may not have a working time machine just yet, advancements in theoretical physics give us hope that one day it could be a reality. One of the biggest misconceptions about time travel is that it's a straightforward journey through a linear timeline. People often imagine it like moving through space, traveling from one point to another. But time travel, if it were possible, would likely be much more complicated. The main challenge is that it requires an enormous amount of energy to warp space-time. According to Einstein's theory of relativity, the faster you move through space, the slower you move through time. This effect, known as time dilation, is real and has been observed in high-speed experiments, such as with particles moving close to the speed of light or with astronauts on long-duration space missions. The faster something moves, the more time slows down for it compared to an observer on Earth. This paradoxical effect is just the beginning of how time behaves differently from what we're used to. Another misconception is that time travel would allow you to change the past easily. The popular idea of going back to prevent a catastrophe or to stop a historical mistake often comes up, but it's much more complicated. The grandfather paradox, for example, questions what would happen if you went back in time and prevented your own grandfather from having children. Would you cease to exist? Or would the timeline change in some other way? Would the act of preventing your grandfather from meeting your grandmother actually cause a new timeline to emerge, one in which you are not born, but the events leading up to your existence still unfold differently? These questions highlight the complexities and potential inconsistencies of backward time travel. The scientific challenges don't stop there. Even if we could manage to send information or particles back in time, as in the case of quantum particles, it's still a far cry from human time travel. The distances and energies involved are astronomical, making it virtually impossible with our current technology. Think of it like trying to move an entire mountain using a shovel. Although we know it's theoretically possible, it's not feasible with the tools we have today. Exploring different theories of time travel, wormholes come to mind. These are shortcuts through space-time that could potentially connect two distant points. If stable, they might allow for faster-than-light travel and possibly even time travel. The concept of a wormhole was first proposed by Albert Einstein and Nathan Rosen in 1935, but it remains theoretical. Then there's the idea of black holes, where gravity is so strong that not even light can escape. Some theories suggest that certain types of black holes, particularly rotating black holes, also called Kerr black holes, could act as portals to other parts of the universe or even other universes. If humans could navigate these black holes, it might open the door to time travel. Time dilation, as mentioned, is a real phenomenon. Astronauts on the International Space Station experience it firsthand, aging slightly less than people on Earth. The difference is incredibly small, only a few milliseconds, but it shows how time can be affected by motion and gravity. In fact, the longer an astronaut spends in space, the more noticeable the effect becomes. While this isn't exactly time travel, it serves as a reminder that time is not a fixed constant. It bends depending on our speed and the forces acting on us. Popular culture has also shaped our understanding of time travel, with movies like Back to the Future and series like Doctor Who offering entertaining takes on what could happen if we could travel through time. These stories often simplify the complexities, but they serve as a gateway to discussing real theories surrounding time and space. For example, in Back to the Future, it uses the iconic DeLorean car to travel through time, while Doctor Who uses a time machine disguised as a police box. These depictions, while fun, also bring the public's attention to real scientific discussions surrounding time and space. Recent discoveries have brought us closer to understanding the potential for time travel. For instance, research into quantum entanglement has revealed strange connections between particles that could be used for communication and possibly even information transfer across vast distances. In quantum entanglement, particles become linked, so the state of one instantly influences the state of another, no matter how far apart they are. While we've only scratched the surface of this phenomenon, it points to the potential for new breakthroughs in time travel. The study of black holes has also provided insights. By observing how matter behaves near these cosmic phenomena, scientists hope to unlock secrets of space-time that could one day lead to travel through time. We've already begun detecting gravitational waves, ripples in space-time caused by extremely violent events like black hole mergers. These discoveries give us clues about the nature of time and space-time itself. Some scientists argue that if we could harness the power of a black hole or create a stable wormhole, we might have a chance at developing a time machine. While this sounds like science fiction, researchers are actively exploring these ideas. In fact, recent advances in quantum physics have revealed new perspectives on how particles behave and may even help us understand how time itself is structured. The more we learn about quantum particles, the closer we might get to realizing that traveling through time is possible, at least for small objects. The most compelling argument for the feasibility of time travel comes from the rapidly advancing field of quantum physics. Experiments with quantum particles have shown that, in some contexts, they can be sent back in time, even though they exist in a superposition, both in the past and the future, simultaneously. While we've only scratched the surface of this phenomenon, it points to the potential for new breakthroughs in time travel. So, what do you think about time travel? Do you believe it's possible, or is it just a fantasy? Share your thoughts in the comments below. If you're curious about more mind-bending topics in science, be sure to check out our other videos.